Hello, everyone. My name is Vitaly, and I'm happy to introduce our first speaker, Sam Newman. Sam is a technologist, speaker, and independent consultant based in London, working with clients all over the world. He works in the cloud and continuous delivery space, most recently focusing on the use of microservice architectures. He's the author of the books, including Lightweight System for Real-Time Monitoring and Building Microservices, both of them published by O'Reilly. Before I give my word to Sam, I wanted to remind you that you can ask questions in Discord chat, Telegram, and they will be announced after the talk. So please welcome Sam Newman and his talk. You keep using that word.
Thank you so much, Vitaly. Welcome, everybody. Thank you so much for coming along today to learn about words and the meanings of words. And I spend a lot of my time talking. It's a big part of my job. A lot of the time I spent my time talking about boxes and arrows. And sometimes we're talking more about things like how big those boxes should be or how small those boxes should be. Other times we're talking maybe about what's inside those boxes, which is often quite an interesting conversation. Sometimes we're talking about the shapes of those boxes. I, of course, have my own preferred flavor, but it's often the boxes that fixate us. And today I'm really going to be talking about the arrows and specifically the nature of how our service architectures, our distributed systems communicate with one another. And fundamentally, when we think about a microservice architecture, this is a little subset of a contrived microservice architecture. We see these arrows. We see the arrows between services. And this being a talk about meaning, I thought it would be important to explain what this arrow represents. So when I draw an arrow in a diagram like this, I'm basically showing a logical dependency. I'm showing that one microservice depends on functionality that another microservice provides. So returns here has some sort of dependency on the shipping functionality, right? So this could be something like the returns microservice needs to, I don't know, get a shipping label so that it can send a package back. I got an incorrect delivery from Amazon the other day. I ordered a frying pan and they delivered me cat litter. I'm not even making that up, right? So I've got to send the cat litter back and they sent me a label. So maybe behind the scenes, that's what's going on here. There's a returns microservice saying Sam needs to send back the cat litter. So he goes to shipping microservice that says, okay, well, based on the weight of the package and where Sam is based, this is the right kind of label to use. And then the label gets sent back, right? That's maybe one way we could implement that. Now, often when we start talking about the ways in which we implement these interactions, when we can talk about things like request response and event-driven, we might talk about different technology, we might mention gRPC or Kafka. It's often useful to try and categorize the types of communication we have. And probably the most I think, common form of categorization that I see people using is this distinction between synchronous and asynchronous-based communication. In fact, many people would say this is the most important thing. And I'm here to tell you that I don't think this distinction is the most important thing in the world. And that's largely because I don't think there's any real good definition about what asynchronous means, which means this conversation about, oh, you should use asynchronous communication between our microservices doesn't mean anything if we can't agree on what asynchronous actually means. And I was inspired to do this talk because I was struggling with this word. What does asynchronous mean? Because I would, different people would have different views of this. There's a great blog post by, it's a newsletter by Pat Helland, who's one of the pioneers of distributed computing, and amongst other things. And Pat ran this great post a couple of years ago now, talking about this term eventual consistency. And he said, well, the problem with that term is that we use the word consistency in lots of different places in computing. And that term has different meanings in those different places, in those different contexts. And so he was actually advocating that we should change the name, that we should call it, eventual convergence was actually the term he coined. And I think it's a better term. The post is well worth a read if this is a topic that interests you. And I was hoping to explore this topic and come up with a better term than asynchronous. Now, I have failed. However, what I am going to take you on is that journey to look at the different types of asynchronous communication that we might see and to explore what that might mean and how that might change how we think about not only how we build our systems, but also change how we communicate with one another. And ultimately, that's vital, right? Because it's groups of people that build software, right? So I thought, what's the best way to kick this off? Well, before Twitter became an unholy tire fire, I actually put this tweet out, and I, because I was struggling with this, and I checked different people. So I thought, let's just see what Twitter has to say. This was back when you could sometimes get a reasonable answer from Twitter. So I said, I think the distinction between synchronous and asynchronous is a bit fuzzy. What does asynchronous communication mean to you? And so I got a whole bunch of really interesting tweets back. I'm going to take you through a lot of those and talk about what that means. And this almost looks at the many faces of what asynchronous computing means to different people, most of whom I respect. So yeah, it's a bit of fun, but also educational. This is one of the first tweets I got back. It was from my old colleague of mine, Darren Hobbs. And Darren said, well, for him, asynchronous communication was the difference between, say, sending an email versus having a phone call. Okay, you pick up the phone, you're talking to another person, there's an ongoing dialogue there, we're having a chat, but it's quite immediate, right? Sending an email, I send an email, and then I may or may not get a response. That response might take a while. And there's also kind of maybe unwritten in what Darren said here, you can send an email to more than one person, which is kind of interesting, right? It's very rare that you do that with a phone call, unless you're using one of those expensive phone lines we won't talk about. But there is an implication, though, from Darren's sort of statement here, is that asynchronous communication will somehow be a slower operation than maybe a synchronous implementation, which we know is not really the case, because, in fact, the majority, or in fact, the most low latency applications I've worked with have used asynchronous communication extensively. So that doesn't seem to necessarily always be the requirement. I think saying asynchronous equals slower isn't really right. But there is something here about the interaction model. So Darren's onto something here. So there's something useful, but we'll come back to some of these ideas a bit later on. So why this Twitter thread was going on, I thought, well, look, people have written things about this. So I looked in books. I looked in Tannenbaum, of course, which is the distributed systems book by Andrew Tannenbaum, which is, of course, the Bible of distributed systems. And it's very interesting that in the current edition, which is freely available, by the way. There are expensive versions available in hardback form, but you can get a free ebook of it. I think the term asynchronous is used like about 5 times in the whole book, and it's a big book. And it's kind of interesting that I think the reason Tannenbaum doesn't use that word often is because there is a lack of definition around it. But the people who wrote the Reactive Manifesto, however, they have attempted to define a bunch of ideas, and asynchronous being one amongst them. Now, I don't agree with everything that's in the Reactive Manifesto. There's some things I like, there's some things I don't like. It's a bit of dogma, which can be useful, right? It's a somewhat extreme view, saying this is how the world should be. And sometimes those things can be useful, but it doesn't mean you have to agree with all of it. I don't agree with all of it, despite the fact that I respect a lot of the people that wrote it and respect some of the ideas in it as well. But they have also put a lot of work into trying to be clear around what they mean by some of these ideas in this. And that was great for me, because they've made an attempt to actually define in the Reactive Manifesto what asynchronous means. So the asynchronous definition, in the context of this manifesto, we mean that the processing of a request occurs at an arbitrary point in time, sometimes after it has been transmitted from client to service. Okay, so on the face of it, this seems fine, but then we start thinking about it a bit more. And remember, this is a definition that's supposed to distinguish asynchronous from synchronous communication. But this sentence doesn't actually really, when you get down to it, mean anything. It feels like it should, right? Let's take another look at it. The processing of a request, so I've sent something to another service or process. So the processing of that request is going to occur at an arbitrary point in time, sometime after it has been transmitted from the client to the server. Okay, what does this actually mean? Because what's the alternative, right? That I'm somehow going to process the request before I've sent it. Like I've got some kind of weird Doctor Who type networking protocol where packets appear before they've even been sent. Of course, it's going to get processed after I've sent it. That is going to be all forms of communication. So unfortunately, it doesn't actually kind of help us in this world, because that is just because of the causal nature of at least our networking protocols. That's always going to be the case, right? We're always going to process something after it's been sent. Otherwise, what the hell? There is other stuff in the interactive manifesto, though. It starts helping us get a bit closer to at least what the authors meant by asynchronous. So they go on to talk about, comparing asynchronous to synchronous. They say this is the opposite of synchronous processing, which implies that the client only resumes its own execution once the service has processed the request. So in the words of the Reactive Manifesto, something is asynchronous if I can send something to a server and then I can carry on doing work. It's synchronous if I send something to another server and then I block and wait until something else happens. Right? So that's what kind of the Reactive Manifesto is saying. That seems to be the case anyway. Let's come back to our Twitter thread, right? Because I'm doing this research in parallel. Twitter thread's going on, off the side. A friend of mine, Steve Smith, does a lot of work in continuous delivery. Works for Equal Experts out in the UK. He says, well, for him, asynchronous communication means that the TCP connection is open for the duration of the communication. This is a bit of an odd response, but I was confused by what it meant. And so I said, well, so if I'm using a different networking protocol, does that change how you think about synchronous versus asynchronous? And actually, Steve came back to clarify. I said, well, actually, I assume with asynchronous, you're not blocking for a response. So this, again, is like what the Reactive Manifesto says. So for Steve, asynchronous communication is not blocking for a response. And really, that's what the Reactive Manifesto was talking about. When they said synchronous versus asynchronous, what they really mean is asynchronous is non-blocking, if you look at kind of what's in there. And that's useful, right? Because non-blocking is a much more explicit statement. And I think if you can be more explicit, you should use a more explicit and clear term. And non-blocking is a much clearer term, as we'll see, than asynchronous. So let's take a look at what non-blocking calls are and why they might be useful. So we've got a simple example here. We've got a microservice that's going to talk to two other microservices. This might be as part of, I don't know, some kind of enrollment process. Maybe a customer signed up for a service or something. And so the first thing we need to do is to award some points to the client, to the user, saying, thank you for doing this. Here's some points that you can cash in at some later date. And at the same time as we're going to doing that, we want to upgrade the subscription. Now, from a business process point of view, these two operations could happen at the same time or one after. That doesn't actually matter that much, but they both have to happen, right? Now, if we ran these, if we implemented this in sort of a somewhat naive way, we might imagine the client code that's inside the enrollment service. We might start by sending an award points request to the server, right? And then we would wait until we get a response. So that res1 object is now represents the response of that request response interaction. And then once we've got that response, okay, we'd then go on to the next line of code in the client and send the next request and then wait until we got a response. Okay, so we sort of, from the client side point of view, you run a load of code, it executes, we wait for the results, next line of code, executes, wait for the results, next line of code, executes, wait for the results. And to be fair, that's normally fine, right? And that's actually how most of us learn how to program. We have a piece of code, and then that, and then that, and then that, and then that. Okay, so that's normally okay. The problem, though, is that when we start invoking external services in that manner, we do have to start considering the impact of latency in our system. So in this situation, where we're running a call and then blocking and waiting, and then running a second call and blocking and waiting, we end up with a latency being the sum of the calls. So we end up with 200 milliseconds of latency, as opposed to ending up, which is much longer than we might like. And of course, there's another variable here in that the latency for these operations is not always going to be fixed. So I'm presenting it here as being a fixed number. I'm saying, okay, it's always going to be 150 and 50. In reality, of course, latency is variable. We have tail latencies to deal with. So this actual range could end up being a lot worse, couldn't it? Right. So that's potentially an issue. So ideally, what we would like to do is to run these calls in parallel instead. So what we'd, rather than doing one call then waiting for the next, it would be much better if we could say, well, then run them both at the same time, because that would allow us to run the operations in parallel, and this whole operation would end up being much faster. So wouldn't it be, so rather than waiting for both, do them both at the same time, and then we reduce the overall latency. And often we would use something like a reactive extension for this to kind of, you can see a reactive extension a little bit like some very useful syntactic sugar in a way. So in this example here, both those requests have been wrapped in a future. So a future is a read-only type, the value of which is going to be known at some point in the future. I mean, maybe it's a Schrodinger type. Anyway, so when the way this works is that first line of code, when it executes, it doesn't, the parameter, what's inside the parentheses there is basically getting packaged up and stuck in a background thread. So when that, as I'm running through that piece of code, when I go, I execute that future line, at that point, the thing hasn't actually happened yet necessarily because it's happening in a background thread. So it's syntactic sugar around making threads happen. But the upshot of this is that those two calls are now happening in parallel. Okay. And so the latency would go down from, say, being 200 milliseconds to being 150 milliseconds. Again, caveat around, latency spreads and things like that. So this already is useful. Our code, actually, the client code doesn't change that much. And we've very easily here been able to make these calls happen in a non-blocking way. The client code is not blocking because we're doing work on background threads. We bring down that latency. This just seems like a good thing. And it is. It actually is. However, we do have to remember that often the reason we make calls is sometimes because we need the answers. And so we may actually need the responses to do something. In this situation here, because of how these reactive, these sort of reactive extension libraries are going to work, once we get to that point, those things may not have finished yet. So when I go and look at the value of future one, it might say, I'm not finished yet, still pending. So if I actually need the results, and I might need the results to confirm that, yes, these points were awarded, or yes, this subscription was upgraded. In other situations, I might need the answer from this operation to do something else with. So it's quite reasonable, even in non-blocking client code, for you to have the results. So how do we get the results? Well, what we would then do is have something like an await. And so here we do an await, which will effectively wait until both future one and future two's values have been computed. That is a blocking line of code, because when that await line goes, the code there will block and wait until those operations have completed. So is this a non-blocking client or a blocking client? And it's like, it's a bit of both, right? So even that distinction is a bit fuzzy. However, so you could remember this, even if you're using non-blocking calls, the logic of the processing, the way your algorithm is set up or whatever it might be, you may still end up having to block to wait for things to happen. And that's kind of unavoidable. So even non-blocking calls may end up blocking. But if you can use non-blocking calls and run those calls, and especially when you're doing multiple calls, if you can run those calls in parallel, then that is still a good thing to do, because it will help reduce the latency of your operations. Exactly how you do that will depend on the programming language you're using and which reactive extension libraries you're using. But if you take a look at how you do things like futures and awaits in your programming language, you'll find the answers there. So let's go back to some of our Twitter thread from earlier, right? Let's look at some of the other responses that came in. Here's another one from Graham. Graham says the definition that he's been using is the sending service doesn't wait for completion of the receiving service before continuing and or completing its own work. So that first part of Graham's thoughts processes is basically the non-blocking stuff. We just talked about it. But then he goes on to say, but now I think about it, I also expect a temporal decoupling from the receiving service's availability. And temporal decoupling is one of those grand phrases we like using in distributed systems. In fact, temporal coupling and temporal decoupling is used in different contexts in computing. So it's like asynchronous has different meanings in different places. But if we take a look at what temporal decoupling means in the context of a service-based architecture, if A is sending a network request to B, and it needs B to be up for it to be able to send the request and to get the response, then those things are temporally coupled, right? They're coupled in time. So how do we temporally decouple things then? Well, another comment on the thread said for them, right, synchronous communication is as a direct communication between sender and receiver, and async, there's an intermediary, or for example, a message broker. And this is where we start getting into some interesting areas about what Graham talked about, which is trying to avoid this temporal coupling issue. So the most common types of intermediary you will see will be some kind of message broker. It's not the only one. We'll talk about some others a bit later on. Message brokers can be useful things, right? Fundamentally, they allow us to decouple the communication. So here I've got service A, which is sending a message to service B. B may or may not be available at this moment in time. And I don't care about that because I am basically giving the message to the broker. And it is the broker's job to deliver that message once B is available and ready to take that message on. So B could have been offline or unreachable at the point where A sent the message. This can open up all kinds of useful patterns. It makes it easier to do things like deploying things on a running system, for example. You could shut down B and bring up a new version of it if you can't do rolling upgrade, and the broker would kind of buffer the traffic for you. So there's all kinds of fun things you could do with intermediaries. So, but this is kind of a useful property. This is why a lot of people use message brokers. So along kind of plowing this particular furrow, another person commenting on the thread said, for them, asynchronous is like dropping a mail in a post box and then going on with your life, and then bam, one day, Postman Pat stuffs something into your house mailbox, along with millions of coupons and charity mailers. And like, this is Postman Pat, by the way. So if you don't know who the Postman Pat is, it was being referenced in this Twitter. This is the OG Postman Pat. The new Postman Pat apparently is a hovercraft, which, I don't hold with. But there is this idea of the intermediary working like that mailbox, like that message box. And it is a useful metaphor, and the technology in this space is really, really useful. It's very empowering. And there are lots of different ways we could implement that kind of inbox, message box based intermediary. Message brokers being the most common, but you could also do this with a database. Your file system is very, very common. I put a file and some other process picks it up at some point later on. I could do this with email. You shouldn't do it with email, but you could theoretically use email as a communication mechanism between servers. But please don't. But the benefit of this is that the person sending the message, I don't need to worry about whether or not the recipient is currently available. And that's great, right? But we do need to trust the intermediary, right? So if I'm giving it to a broker and having the broker deliver it, I need to trust that the broker is reliable, that's going to keep the message safe and everything else. And that's where a lot of the complexity comes from in terms of how the brokers themselves are implemented, and also the associated administration costs of those things. So if we're thinking about a classical request response based interaction, we could see how that might work on top of a broker. So I've got service A here, which is going to send that request. So before I was talking generically about a message, now we're talking about a specific type of message, a request. And so service B might have its request queue, and I put that request in service B's request queue. Service B picks that message up, that request up, does its processing, and then when it's got a result, it can put it back on a response queue, and I can then read the responses from that. So basically, in this case, both that request queue and that response queue would effectively be owned by service B. So pretty straightforward, right? So that's taking what you would traditionally think of as maybe being, so now what we've done is we've gone from, say, if you were just opening up a network, a HTTP call and making a direct call, we've now put an intermediary in place, which has kind of created this sort of non-blocking flow, well, potentially non-blocking again. They're still up to how we've implemented the client code. But if we'd also use that, sort of asynchronous style of communication in the client code, we would have non-blocking, and we'd also at this point remove temporal coupling as well. It's a little bit more nuanced than that though, because the reality is when you start looking at how all this stuff is going to work, there's no guarantee that the response is going to come back to the same instance of the service that sent it. Some brokers give you support for this, but in general, I actually think you should avoid that. It's more likely we've got multiple instances of service A. And so when I send that request and it gets to B, and B sends back the response, there's zero guarantees that that response will come back to the same instance of A. And I personally think that is a good thing. The reason I say that that is a good thing is because when you look at the complexity that you need to add into these systems to make that response get back to A, that complexity adds more sources of problems and issues and failures, and in some cases, performance hits as well. And also the idea that you want that response to go back to the same instance of A implies that you're holding on to some in-memory state. And at which point I have to ask the question, what happens if A dies, if that instance of A dies? And that could happen at any time, right? That could just go, poof, it's gone. Whereas if you build your system and implement your code when using brokers like this in such a way that that response could go to any one of your instances, then actually you'll find out your system is much simpler and much more robust as well. And you don't care if nodes die. You're not trying to do any fancy, in-memory cluster sharing type nonsense. Keeping your processing stateless. This is ultimately what we're trying to do, right? We want our processing to be as stateless as possible. We come back to our non-blocking code earlier. Now here, kind of the way the code is written, the responses have to come back to the same instance of a service, right? This is the process, we're running the code. I'm doing that. That's what I'm expecting to do, okay? So theoretically, the enrollment service could die halfway through this processing. And those responses might be flowing back to a process that's no longer there. You've got to think about how that's going to be dealt with. In practice, typically the way you handle that is just you retry the whole processing from the beginning, which then in turn means you need to make sure these things are idempotent in nature. But fundamentally, I quite like when the forcing function here, right? By having an intermediary and by thinking about that response potentially going to a different instance of the thing that sent the original request, it actually encourages sort of stateless processing of those responses. So if you can implement stateless processing of that response when it comes in, you'll find so many other things will become much, much simpler. And this is definitely the way to go. We've got all these competing definitions, right? On the one hand, we're talking about how immediate things should be. We're talking about temporal coupling. We've got non-blocking. We've got intermediates as well. And it's like, well, this is confusing, right? So can the real asynchronous communication please stand up, right? Which one, when we say asynchronous, what do we really mean? And there is also an extent to which we can say, does it even matter? Because we use different words to mean different things all the time. Words have different meanings, and we are used to this. So, little guess and game. What words in the English language do you think have the most meaning? If you're on Discord, you can put your guess in. So what words in the English language have the most dictionary meaning? Give you a moment to think about that. Guess what it might be. So, in the current official edition of the big set version, it's actually the word set that has the most meanings in the Oxford English Dictionary. Although in the new edition that's going to be coming out 2037, I believe, it's going to be run. Set has 430 different meanings. Run has 645 as of 2011, right? I suspect that number could increase. So we kind of, though we think, well, we know what these words mean. And the fact they've got loads of meanings, is it an issue? Let's explore how we deal with this. How do we understand when someone says set or run? How do we understand what that word means? And actually, in isolation, it's quite difficult. The way we derive meaning from a word, though, especially a word that has lots of potential meanings, is, well, basically by increasing the context. The more context we have around a word, the easier it becomes for us to understand what it is and what it means. This is something that Ian Cooper helped me understand. Obviously, Ian Cooper has many people have a hinterland. Ian Cooper's hinterland is massive, and he obviously studied semiotics at university, which is the study of meaning. And he was explaining to me that the meaning of a word becomes more narrow as we add other words around it. And so when you want to be specific in terms of your language and your communication, having more words around it actually helps refine that meaning. You work out what definition or what meaning of run is intended based on the other words that we put around it. We're going to do a quick exercise. You'll see how that works, right? I want you to think of what the word run means to you. So picture in your heads right now, run means this. This is what run means to me. Now I'm going to put some more words around it, and let's see if my meaning of run and your meaning of the word run match. The issue got worse the moment the program was run. Did we have the same meaning? Maybe we did, maybe we didn't. Let's try it again. Think of a different type of meaning for the word run. Think of some other meaning that run has for you. Have that in your head. Picture that in your mind now. Now let me add my words around it. The economy crashed due to a run on the banks. It's possible that meaning of the run that you had ended up being the same as mine. It's quite possible it didn't. But when I added the other words around it, you immediately understood what run meant in that context. So where more am I getting at here? The issue is we often talk about synchronous, asynchronous. We throw these terms around without putting the other words around it. We don't give context around asynchronous to help people hearing that understand what the communicator meant by asynchronous. We don't put enough context around this generic word to give it sufficient meaning. Coming back to the Reactive Manifesto, they actually talk about the Oxford English Dictionary's meaning of asynchronous. But for reasons known only to them, they decided to just pick the top one rather than actually looking at the definition of asynchronous that's actually in the context of computing, because the original one is only supposed to be used in medical contexts. So actually, if you do go look at the Oxford English Dictionary, there's a whole section of meanings specifically in the computing domain. That's not the definitions used in the Oxford English Dictionary. And when you look at that definition, this is actually definition for one of the two definitions for asynchronous in computing. This is the closest to what we're talking about. This is the definition that actually is used in the context of network-based communication in the OED, right? Asynchronous designating data transmissions in which packets of data are sent at irregular intervals, with the start and end of each packet being marked by specific signals involving such transmissions. I don't know what that means, and I do this stuff for a living. This is the Oxford English Dictionary is basically a research tool, not a definition. It's not a tool for helping meaning necessarily, but this has no meaning to me either. So let's put this off by the wayside. We have to recognize, though, where am I going? That software is fundamentally a type of socio-technical system, right? Software is if we start thinking, socio basically is a mix of people and technology. And at this point, you might start thinking, oh God, here's some left-wing liberal snowflake to talk about how we always get along and, smoke dope and talk about our feelings when writing code. But actually, this is stuff that came out of the study of coal mining during World War II. Socio-technical systems are about understanding how people and technology relate, because it's ultimately people that build things. The amount of software created by individuals is vanishingly rare. And I bet if you can cite an example, I can point out how you're wrong in any of the famous ones, right? We bring people together to create software. So to create software successfully, it does require good communication, because that's how people work together. You don't want two different people with very different views about what the term asynchronous means, because you end up building maybe a disaster. And we have prior art for understanding this. We go back to the Old Testament and the Tower of Babel. Okay, the people of Babel were building this glorious tower, and they all spoke of one language. It's a very short section in the Old Testament. It doesn't just talk about the fact they all had one language, and that's why it was easy for them to build this. They also talk about modern building techniques as well, but that often gets ignored. But nonetheless, they had a people of one language. And the Old Testament God didn't like what they were doing and made all their language different. Might have been having a bad day, who knows. Net result, the tower didn't go so well afterwards. So we have this idea back in the Old Testament of language and communication being important, and speaking different languages and having different meanings also being a detriment to, large building projects. The term asynchronous in the context of inter-process communication has so many meanings that it is effectively meaningless, though. So what do we do about this? Well, understand what your application needs. Don't worry too much about fashion or what the Reactor Manifesto says. Think, for our application, for our context, what do we need our application to do? And then describe how it should handle different situations and communicate around how those things are going to be handled. Be more explicit for your context. Ask questions like, what do we think should happen when a server is unreachable? What do we want to do in that situation? How fast does our application need to be? What should we do if the client crashes? And describe how you want to handle those situations. And where possible, do use more explicit terms. Say clients should be non-blocking. That has meaning. And it's easy to be explicit about that. Say that you want operations to be run in parallel. Say that you're going to use a broker as an intermediary. These are all more explicit concepts. But, try to do it in a nice way, right? Try not to be going around policing people. Oh, you don't know what asynchronous means. They may just have different meanings. In The Princess Bride, when Vinicus is using that term incorrectly, and it's, Mandy Potemkin is like, just, in Game One Toe, obviously, it's just gently correcting him. Are you sure that word means what you think it means? Of course, the joke in The Princess Bride is that all of us know what inconceivable means, and Vinicus doesn't. And that's not actually the case with asynchronous communication, because I think what you'll find is probably all of your colleagues might have different views about what it means. So maybe you should go ask them, when someone says we should make this asynchronous, maybe you should just ask, well, what does that mean to you? Because what you find might shock you. Anyway, that's me done. Thank you so much indeed for having me. There's loads more information over at my website. Very happy to answer questions now or take some questions on Discord. But thank you for your time.
Thank you, Sam. This was such a great talk. Such an intersection of psychology, technologies. It was cool. We actually have some questions. One question for me, a bit more simple, but still. What's your opinion on blue-green functions, async explicit async versus implicit async, discourse, all this?
I don't. To be honest with you, it's not something I've spent a lot of time focusing on. I tend to think kind of more about I spend more of my time thinking about network packets, if you think about that, than the code. Oh. So I don't really have a strong opinion on that from that point of view.
Okay, that's also the answer. Okay, we have another question.
I do have strong opinions about some. There were some things, Vitaly, I have very strong opinions about, and I'm very happy to talk endlessly. As I've got older, there were some things I'm like, do whatever makes you happy about other things.
Okay, yeah, but this potentially this can bring a lot of division into languages and into communities. This
I think it's
duality.
Yeah, but I think there's always duality of meaning in any place. I think the important thing is to describe how you as a team want to work together, right? I think there's the community and then there's what you want to do internally. I've worked with organizations where they can't use the term microservices. I'm working with one right now because somebody used microservices previously and it was a disaster. And so they want to do it again, but they can't use that word ever again. So I'm actively working with a client like that right now. So what I'm having to do is translation. That's absolutely fine as long as you can find a way to work within your group. I work with a Brazilian and a Chilean team, so the Brazilian team speaking Brazilian Portuguese, the Chilean team speaking Spanish, and they had to agree, and Spanish speaker, they can kind of understand what each other's saying to an extent, but they ended up just defaulting to English as a way of communicating with each other in terms of the written stuff they were doing. It's about, I think, finding what works for you, and language is useful, but maybe spend some time to define what you mean.
Yeah, I understand. Language is just a medium, like for expression.
Yeah.
So yeah, from that standpoint, it's really relevant. We have another question in Discord. Hypothetically, if there are no issues related to latency, would async communication still make sense from other architectural points of view? So if you have like a zero latency, should we just be synchronous everywhere? Not.
Well, as I mentioned, don't assume that asynchronous communication is slower than synchronous. It's often not. A lot of these synchronous communication mechanisms we use, the differences are not anywhere near what you think they might be. And secondly, of course, there is no hypothetical world in which that's the case because latency is always a thing. But putting that off to one side, even if we assume that we don't care from a latency point of view, are there still benefits in some of the asynchronous forms we looked at? Well, yes, because remember, I broke apart some different types. I talked about asynchronicity as not blocking. That's one aspect. But even if I wasn't going to do that, what about temporal coupling? You say that latency might not be a factor, but the thing you're talking to may not be there right now. So there may be other reasons to look at some of the aspects of the asynchronous thing we peeled apart, even if latency wasn't an issue. If the thing you talk, the two golden rules of computing are: one, you can't beam information instantaneously between 2 points in time. Now, you're saying you kind of choose to ignore that latency issue. Fine. The second golden rule of distributed systems is sometimes the thing you're talking to is not there. And so that intermediary form of asynchronous communication we looked at towards the end there does have benefits, as it is at least one mechanism to potentially sort of temporally decouple you. So there might be other reasons to do it.
Yeah, the main probably reason for me personally is like a decoupling and like decreasing an amount of errors inside the system to some reasonable amount.
Yeah.
Okay. Thanks for the questions. You can continue communicating with Sam in Discord voice channel. Thanks again for the great talk.
Yeah. And thank you so much for hosting me, and thank you for inviting me. And hopefully next year we'll do this in person.
Oh, that would be cool. Yeah.